you can either create a new project, or you can use an old project, by which I'm going to use an old project. So even though I have churn here, and this project is for the telecommunication company, it really doesn't matter that much, because I keep every data set in the same folder. I like to use the same library, and that's it. So I'm going to create new data source and new diagram, and build the project here as if I'm creating a new project. So the first thing is to create the data source. The data set is ClassifyRisk. You all have the data set, right? Do you have the data set? You can download it from week 5 folder. So I hope you can follow along, because this will be almost what you're going to do in the homework, although it will be on a different data set. So I can use the basic metadata, and we'll take a look here. So first thing is we have to decide which one is the target. So the risk here is the target. And although it's binary, but being nominal would be fine. Mortgage is nominal, binary, same thing. All the others, number of loans, is nominal. Yeah, it's according to the PDF, it's changed them to nominal. But something is happening here for let's see, for the k nearest neighbor algorithm. It's called memory-based reasoning, MBR, memory-based reasoning. So this algorithm in SAS doesn't take into account the nominal variables for input. So for MBR algorithm, as well as for your homework, the standard approach would be to let the model only use interval variables. So here there are only 2 interval variables here, right? So the model will really only use 2 of that input variables, as well as the target. Huh? Do you have that? Do you have this week's PDF? The MBR? Yeah, you can do according to that. So confirm that you have 2 interval, 1 or a bunch of nominal. Okay. Now you can create a diagram. So a couple of things to keep in mind. Usually you would do, and in the same case here, we would do Static Explorer to understand you know, the basic statistics and missing values. And we'll do that. But let's see, before that, I would also include the intervals as the variable worth, and then we'll run.
What was it?
I changed the chi-square stats for interval as yes, that's a floor, yeah. So review the missing values. There's no missing values. There are let's see, 123. So there are 246 total points. 123 are good credit, 123 are bad credit, so 50-50 split. No missing values for the nominal variables, no missing values for the intervals, so which is great. And that's it. Well, take a look at the rank. The income obviously is shows up to be the most correlated variable to the target, and same rank here for income, although different heights of the bars, but roughly similar, right? The order in which the correlation of the inputs are: income is the most correlated, age is the next, and marital status and loans, although the middle three are relatively similar. As for loans, number of mortgages doesn't indicate too much about the credit risk. Okay, now for a supervised project, normally you would do the partition to enable the cross-validation. For this homework, you won't do it because you only have 10 points, right? And you need to answer questions about the 10 points. So you will skip the partition, data partition. And that's what I'm going to do here. I'm going to skip the data partition. And we will do the MBR model, memory-based reasoning. But before doing that, there's a critical step you have to do, is to standardize the variables. Standardization makes the scale of the variables doesn't matter. So sometimes the variable has large ranges, like income, from 0 to maybe 1 million. And sometimes the other variables may have smaller ranges, like age, ranges from 18 for this data set to maybe 100. So smaller windows. The scales of the variables make a big difference in terms of calculate distances, right? The original scales, the variables that has wider ranges will have more weights, will be more influential when you incorporate them in the distance calculation with other variables. But you don't want that to happen. You don't want the scale to make a difference. You want the scales to have the same influence. So you need to standardize the ranges of the different variables. That's when you use the standardization tool. Do you remember where the standardization tool is? Which node is it? Yeah, it's a very powerful, useful node, right? The data transform variables. Right. The first thing here is, we'll go into formula and take a look at the distributions. And we may have to update or run the node before we can see that. where we can see that. So the first thing to look at is income. It ranges from 15,000 to 78,000, a somewhat narrower range than I would expect, but because this is a smaller data set, this looks normal. You know, more concentration on lower ranges, and a right tail skewed distribution to the right. They all look very normal. In terms of age, it's fairly normally distributed with the symmetric tails and concentration in the middle, but still a wide distribution. So all of these good. Marital status, there should be 2 or 3 categories, and look good. More singles than married. Others include divorce and other things. Number of loans between 0 and 3 look normal. Number of loans means the number of currently effective loans. So how many loans do they have currently are liable to? Number of mortgage, yes or no? Do they have mortgage as well? And this data set is to predict the risk of mortgage default. So having a mortgage concurrent, maybe indicative. But as we see the rank of the variables, mortgage doesn't make much difference. Okay, so the point here is really to review the distribution to identify any problems, right? If there's no big problems here, then you will standardize the variables. But keep in mind,
Dr. Wong, could you please click back on classify risk? No.
Classify risk, yeah. Mm-hmm. So what information are you trying to see?
Oh, just to see what changes you made.
I didn't change for the data source. Yeah. So it should be fine as long as you drag and drop. For transform variable, you don't want to change anything else for now because you didn't see any other problem. The only thing you need to do is to standardize the ranges. So you make sure that every default methods is turned off, no default methods clicked is effective. And something I forgot to do, and it's not too late to do that. Make sure I have a random and max for the sampling. And rebin, that's fine. We'll look at the data set distribution, that everything looks fine. So then now it's time to go into the variables to choose specific standardization. For nominal, it's not possible to range standardize. It's only for the interval. Right, for the 2 interval variables, I will select them and I will do a batch change modification here. I will choose a range standardization. What it does really is to make sure the 2 variables here, the age and income, after transformation, the values of these 2 variables both have minimum 0 and maximum 1 after the transformation, so that their arbitrary scale don't matter much. The arbitrary scale should not be incorporated into the distance calculation. So that's why it's very important to do that here. Make sure you click you confirm, you click OK, and you can run. Review the results. Make sure that the variables that are supposed to be transformed are indeed transformed. So you can see what happened in the background. So the 2 original variables are transformed, it has a range prefix. That means range standardization. So this is the formula that's applied to all the values of age and become the range age. So it takes the age and subtract by 17. What is 17? 17 is the minimum value. It's the floor, if you will, the floor of this variable, right? If you subtract all the value by 17, then you make sure the minimum after transformation is 0, right? That makes sense? And then the denominator is 66 minus 17. 17 is the minimum. What is 66? That's the max, right? So then you divide the difference by the range. It makes sure the maximum is going to be 1.
So it's going 1 by 1, 17 minus 17 divided
Yeah.
by...
Yes, 1 value by 1 value. Yeah. And the same thing for income, except that the minimum and maximum changes in this case. It's some much wider ranges. But after transformation, it becomes 0 to 1, right? So that's good. All right, now you're ready to apply the model. Under model, it's a very white tile with points and curve in it. Yeah. Let me make sure. There's a caveat to this node. Very weird behavior. So, let's say when you calculate distance between a point with all the other points, that that point with question mark, you can still count that point as a point, right? So hypothetically, you can always find the closest point, which is the point itself. It's the self-image, if you will, in the data set. But we're not supposed to include that because that's the same point. That doesn't make sense. That happens for all the points. So by a better way of implementing k-nearest neighbor is to not consider the point itself and only consider the other points, right? By including the point itself, it incorporates a little bias, which is the label of the point itself, which is the bias, right? It's biasing toward itself, which doesn't make sense. But SAS automatically include that point as one of the k. So if you say we want k equal 3, meaning 3 different points, but then if you say k equal 3 here, it will only count 2 other points, and then include the point itself. So, but you really want to counter that bias. So you would include 1 more. Right? If the question asks for 3, you would choose 4. So always increase by 1, just for the problem's sake. Here the number of neighbors is the k, right? So if the question asks for 3, you would use 4, and you'll see the 4 points, which include the point itself. Question? And then not much. This algorithm don't matter that much. It changes slightly the calculation of the distance. So that's when you are ready to run. Create. These are default settings, and it's fine to keep them. Create neighbor variables. Meaning, for the output data set, you'll have extra columns to indicate which neighbors are the closest neighbors to this point. Right? If you ask for 4 neighbors, it will create 3 more columns to indicate the neighbor 1, 2, 3. Right? So you need this information because you need to answer that question in the homework. So I'll skip these graphs. These graphs will be useful after we talk about it. The concepts such as lift, gain, cumulative, they will be talked about in toward the end of the model evaluation stage. So the main thing we do here is to confirm that the model ran and to look at the summary of the results. Model events. So the target variable is the risk. The meaning of that, the label of that variable is good risk or bad. It's just the meaning of that variable. There are two levels. Number of levels are 2. Descending meaning, the larger value means the good risk, basically. Anyway, so this confirms that the model runs. To answer the question of which neighbors are the k nearest neighbors of a particular point, you need to go into the exported data set. Do you remember how to get to that? So once you get there, you'll browse the data set, right? Where do you find the exported data set?
MBR.
Yeah, MBR.
And then export data set, you click the 3 dots.
Exactly. And there's only one partition here, right? Because we didn't do partitions. So you'll find all the points here.
Yeah, MBR.
So click that MBR. You want to extract the data set after running this model, right? So exported data, you'll see a list, and you can only find one data set that's available. You'll click that, and then you'll browse the data set. So this is the data set. Look at and it does have other like reporting related columns like warnings and some other contextual information about the model. So a little bit explanation here. So this is the column where the prediction is made for this observation. Observation number 1. Prediction label is 1, and the label of 1 means bad risk. Is a primary outcome that it's interested. In this case, the predicted value of the outcome is bad risk, not good risk, because bad risk has a value of 1. It's predicting bad risk, not good risk. And comparing let's see, residual, nearest neighbor, and you have the outcome this is the actual outcome of the original data, right? This case is actually bad loss, is bad risk. That's the actual outcome. But when you apply the k nearest neighbor, it ignores its own label and try to use the other neighbors labels to predict this point. So based on those neighbors, the prediction was also bad risk. So there's no residual. And here are the nearest neighbors. The nearest neighbor include the point itself, as I said. The algorithm always does that. Other than that, there are 3 unique neighbors. The neighbor number 4, 44, and 90. And at least 2 of them are bad risk. So that's why the majority vote will give you the bad risk prediction. Right? We can check that. Number 4, 90, and 44. Number 4 is bad loss, is bad risk. And number 44 is also bad loss, so at least 2 votes, right? And number 90 is also bad loss. So, you know, it's a unanimous vote for the bad loss situation. And are they all bad loss? Not necessarily. These points are good loss. So points close to these points will be assigned good loss based on k-nearest neighbor algorithm. Does it make sense? Does it give you a good visual illustration? So this is almost, you know, how your homework process will be if you haven't done it. Any other questions for k-nearest neighbor?
I noticed like everyone can have like different values for nearest neighbor. That's normal, right?
Everyone, you mean every row?
It's like
Just not like us. We don't
With your,
compare each other.
you sure?
Like we ordered by like.
Yeah, when you order things, then the different rows are for different value points. Yeah, if you want to really compare different projects on the same data set, then you need to make sure you have the same sorting mechanism, right? You have a ID column to identify the same point, and then you can compare. Any other questions?